All right, so now we're going to take a look at some formulas that we are going to use um, from certain fire calculations that we're going to see down the road. And we need to introduce these now, and then we'll revisit them when we get to the specific scenarios down the road. So some of these, again, just like the previous section, some of these you may have already seen or done before. Maybe it's been a while since you've done some of these. But we'll just revisit them just to make sure we're all on the same page. The first thing that you need to figure out or to calculate, formula that we're going to use is determine the perimeter of a rectangle. Okay, so for example, you need to figure out in this particular room, where was this fire happened, what's the size of this, what's the actual dimensions of this room, you need to figure that out, calculate it. If you have a rectangle, typically, rooms are either rectangular shaped or something very similar. In a rectangle, we have two sides that are equal to each other and the other two sides that are equal to each other. Usually the longer side is called length. Okay, and then the shorter side is for width. Okay, so in order to calculate the perimeter of that rectangle, we will just simply add together all of these lengths. We have two lengths and we have two widths, right, on opposite sides of this rectangle. So we say the perimeter then would be 2 times the length plus the width. So for instance, if let's say the length on this side here was 10 meters, and then the width was, let's say, 7 meters, then the perimeter of this particular rectangle would be 2 times the length. So the length was 10 plus 7. And again, this is a mathematical operation, involving, in this case, two operations that we're doing. I'm going to do the parentheses first. So 2 times 17, and that would give 34. And then our unit here, because again, these are the measuring dimensions. M, we haven't talked about units in a whole lot. We'll talk about this next week, but just so that you know, M here is the unit, the symbol meters, right? And we're going to talk a lot about metric units in science, because that's what we use explicitly. Really don't work with, feet and pounds and all that stuff, even though those are the units you're used to. In science, we actually use the metric system. Okay, so the perimeter we just add together, because in your rectangle, guess what? This side is also 7 meters, and then the length here is also 10 meters, right? So if you add all of these together, okay, 10 plus 7 plus 10 plus 7, that will give you the same 34 meters. In the case of if your rectangle is actually not a rectangle, but let's say it's a square. If you remember, in a square room, for example, all of the sides are equal to each other. So let's say, for example, that this side here was 5 meters. And then in a square, all of the sides are equal to each other. 5, 5, 5. So the perimeter of this, of the square, would simply be the length times 4, because they're all the same. So 5 is 4, that's going to give me 20 meters as the perimeter. Okay, so perimeter of a rectangle, perimeter of a square. Let's take this one step further. Let's say we wanted to determine the area of a rectangle. Again, you're doing your fire investigations. You need to figure out, well, where this fire happened, what was the area of this room, right? Again, most rooms are rectangular or square rooms. We can calculate that area for rectangle is simply equal to the length times the width. Okay, so if I have that rectangle above, the length there is 10 meters, and then the width is 7 meters. I multiply them together. So 10 times 7 gives me 70. Okay, and now this is something to consider. You're also not just multiplying the numbers, you're also multiplying the units. So meter times meter Let's actually separate this out. So we have 10 times 7, and then the unit here is meters times meters. Right, so that's saying we have 10 times 7 is 70. Meter times meter is meter squared. Because meter here is the same as meter to the 1 and meter to the 1. And when, if you remember from your exponents, when you multiply your exponents, you simply add these two together. So we end up with meter squared as our unit. And when you find the area of something, typically we have a square unit that we're dealing with, whether it's square meters or square feet or whatever. Sorry, unit of length you're dealing with. For the area of the square, it's the same thing. We just multiply the length times the width. In this case, the length and the width are the same. So that would be 5 meters times 5 meters. 5 times 5 is 25. Meter times meter is meter squared. Okay, so that's very, very, very often something that students forget to consider is not only are you squaring in the cases, not only are you squaring the dimension, you're also squaring the units as well. Okay. So we talked about perimeter, we talked about area. What about if we had a three-dimensional object, like a cube or a rectangular solid? Let's say now, I have a room. Okay, so the room again we said is typically rectangular. I'm going to try my best here to draw a three-dimensional. A little bit better. But this is my rectangular room. So hopefully you can see the three-dimensional nature of this. So I have a length along the side. Let's say for this particular rectangular solid, the length again is 10 meters. And in this case, let's say that's the depth. And then this part here, this is the height. And let's say the depth here is, let's say 7 meters, and the height, let's say is 3 meters. So what we can do now, because this is a three-dimensional object, we can calculate the volume of this, the amount of space that is in here. And we're going to need to calculate space in a particular room, whatever. We're just going to multiply all of those 3 dimensions times each other, right? So we have the length times the width times the height. This is the depth. You'll have, different terms being used to represent the different dimensions. It's the 3 different ones that we're multiplying. So length here times depth, height. Okay, so the length, we have 10 meters. The depth there is 7. And then we have 3 meters. Okay, so again, we multiply the numbers 10 times 7 times 3. And then the units, meters times meters times meters. So 10 times 7 is 70. 70 times 3, that's 210. Then meter times meter times meter, that would be meters cubed. Okay, so we have the volume of this rectangular solid is 210 meters cubed. Okay, so we can calculate the area of a rectangle, the volume of a rectangular solid, or the room, if you will, and then the perimeter of that rectangle as well. All right, so let's take a look at some circles. So if I have a circle, and I needed to go, first of all, let's talk about the different ways that we describe a circle. So the distance all the way around the circle, so this distance here, that is called the circumference. Okay, or if you want to refer to it as the perimeter, it's the same. It's the same thing, but we use the word circumference to refer. Let me do this in a different color. So we can distinguish and differentiate that. So this here is the circumference. And we'll do that thing as well for the perimeter. Distance all the way around that particular object. From the center of the circle to the outside, that is known as the radius, and put on the outside. Let's do that in orange. Okay, so that's the radius. We often abbreviate radius as R. And then if you were to go through from one side of the circle to the other side through the middle, then we end up with the diameter. Diameter is often abbreviated D, and as you can maybe see here, this radius is the same distance as this distance, halfway across, which means then, a simple bit of math, we would find that the diameter is actually equal to 2 times the radius of that circle, okay? Those are the things that we need to consider when we start looking at calculating area and circumference and all that stuff. So first thing I want to take a look at is how do we determine the circumference of the circle, distance all the way around. Okay, and the circumference is 2 times pi times r. So this is the constant pi, pi. And we have 2 pi r, which is the same as 2 times r times pi. And guess what 2r is? Well, 2r is the diameter. So this is the same as saying the diameter is pi. Okay, so that's the circumference of a particular circle. And again, pi is something that you can, you don't need to memorize this. It's a constant. You can plug it into your calculator to determine what the circumference is. Similarly, if you have to determine the area of a circle, okay, so the area here would be pi times r squared. Pi r squared would be how we determine the area of a circle. Now remember, the radius, I go back to my original relationship up here, the diameter is 2 times the radius. Another way of saying that is the radius is the diameter over 2. It's half the diameter, right? So like this green thing here is half the distance of the diameter. So what I can do is I can take this relationship, radius equals diameter over 2, I can stick it in here, and I can say the area of the circle then is equal to pi. Now we're saying r is the diameter over 2, and now we need to square it. We end up with this. So if we evaluate this part of the equation, end up with pi times d squared, so d times d over, well, let me write that out actually. So we end up with pi times d over 2 squared. That's the same as saying d times d over 2 times 2, right? That's this region here. So this then gives us pi times d squared over 4, and that's equal to the area. So depending on, what you're given, if you're given the circumference, oh, sorry, if you're given the radius or the diameter, you can plug it into the equation. And again, knowing what the relationship between the radius and the diameter is, it's a very simple relationship. You can use any of these equations to determine the area of a circle. Let's take a look at if we had a sphere. Okay, a sphere you can think of analogous to like a ball, for example. It's a small ping pong ball, whatever, tennis ball, that general shape. is what we're looking at when we're talking about a sphere. What we can do is we can calculate the surface area of a sphere as follows. So the surface area is equal to 4 times. And again, r here is a radius. And then similarly, we can, so that's the surface area, right? The outside, total area on the outside of that sphere. We could also determine the volume of that sphere as follows. So we have 4/3. So 4/3, pi r, then r is cubed, right? So again, we think about, again, r is the radius. If you think about the units, and again, we haven't talked a lot about metric units just yet, but if you have a radius, which is a distance, and you square it, you end up with, for example, square meters, which is the same unit that we saw when we determined the area of our rectangles and squares up here, right? So there was, square meter for both of these. And then similarly, when we did the volume, we saw that the unit was a cubed version of that length, right? So cubic meters. And similarly, if we were to determine the volume of the sphere, we would take that radius and we would cube it. So we end up with, if it's measured in meters, it would be a cubic meter would be the unit. Okay, so as long as we know what the radius is or the diameter, we can calculate any of these things: the circumference of the circle, the area of the circle, the surface area of the sphere, or the volume of that sphere as well.